In this video, I am going to talk about random variable. A numerical description of the outcomes of a probabilistic experiment is a random variable. Random variables are of two kinds. They are discrete random variable and continuous random variable. Let's define discrete random variable. Discrete random variable can only assume a countable number of values. For example, let x be the number of heads obtained when two coins are tossed. So here the possible values of x are 0, 1, and 2. Because when we toss two coins, we can have 0 head, 1 head, and 2 heads. Now, let's define continuous random variable. A random variable that can assume only a countable number of values is continuous random variable. For example, let x be the heights of randomly selected students on campus. Here, we can have range of values. It can go from 60 inches for the shortest student to 70 inches for tallest student. For example, for x, we can have any number between 60 and 70. For instance, a student can be 65.2 inches tall, another can be 65.7 inches tall. Therefore, we have infinitely many possibilities of x. Now, let's define probability distribution. A table or a graph showing random variables x and their probabilities px is probability distribution. Basically, if we draw a table or a graph that has x values and their probabilities, then it is probability distribution. So let's look at this example of probability distribution. A coin is tossed 2 times. Let x be the number of heads obtained. Construct a probability distribution for x. Here, random variable x is the number of heads obtained. So first, we need to identify possible values of x. Since we are tossing a coin 2 times, we need to think about outcomes in terms of number of possible heads. Here, number of heads we can have are 0, 1, and 2. So let's put them down. So they are 0, 1, and 2. Now, to find the probabilities, we will list sample space first. So for that, we can use a tree diagram. So let me make a tree diagram over here. So on the first toss, we will be getting head and a tail. So this will be first toss. And for the second toss, we'll be getting head and tail as well. So these are second toss. And let me put all the outcomes here. So looking at these branches, this outcome will be head, head. Looking at these branches, this will be head, tail. Looking at this and this will be tail and head. And finally, the last one will be tail and tail. So therefore, our sample space is, let me just copy those outcomes here. Head, 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 tail, tail, head, and tail, tail. So now we are ready to find the probabilities of getting 0 head, 1 head, and 2 heads. So on the sample space, we consider the outcome, this tail, tail, to be 0 head. So for this one, probability of getting 0 head is 1 out of 4. So 1 out of 4. So let's look at this when x is 1. So when x is 1 means we are looking at one head. So on the sample space, we consider the outcomes head, tail, and tail head. So we have 2 out of 4. 2 out of 4. So finally, when x is 2, we are looking at 2 head. So on the sample space, we consider the outcome head, head. So we have 1 out of 4. So this is the probability distribution for the number of heads. Now let's look at probability distribution requirements. For a probability distribution, we have these two requirements. So the first one is its probability must be between 0 and 1 inclusive. And the second one is the sum of all probabilities must be 1. So here we need to find out which of the following are probability distributions. So let's look at this one. So for us to decide if this is a probability distribution or not, we need to remember that its probabilities must be between 0 and 1. Okay, so let's look at here. So this is good. So the value is between 0 and 1. Same here, and same here. So basically it passes the first requirement. So let's look at the second one. So the second requirement is the sum of all these probabilities should be 1. So when we add them up, the sum of the probabilities is not equal to 1. So that's why this is not a probability distribution. So let's look at this one here. So our first requirement is its probability must be between 0 and 1. So this value is between 0 and 1. Same with this one and same with this one. When we add all these probabilities, their sum is equal to 1. So therefore, this is probability distribution. So let's look at this one here. So let's find out if its probabilities are between 0 and 1 or not. So this is between 0 and 1. This is also between 0 and 1. And this is also in between 0 and 1. So let's look at the second requirement. So the sum of all probabilities must be 1. So on here, the sum is not equal to 1. So therefore, this is not probability distribution. Similarly, on this one, let's look at the first requirement, which is all probabilities must be between 0 and 1. So let's look at this one. This is between 0 and 1. This is between 0 and 1. So this is not. So that's why this is not probability distribution. So let's look at this one here. The first requirement is all the probabilities must be between 0 and 1. So this probability is between 0 and 1. So is this one here too, this one here too. But this one is not, because since it's negative. So this is not considered as probability distribution. Let's look at this one. So the first requirement is probabilities must be between 0 and 1. So this is between 0 and 1. This is, and this is also between 0 and 1. and this is also between 0 and 1. So when we add all these probabilities up, their sum is also 1. So therefore, this is probability distribution. And this one here, this probability is between 0 and 1, and this probability is between 0 and 1. And also when we add these two probabilities, its sum is equal to 1. So this is probability distributions. And the last one, so this probability is between 0 and 1. This probability is also between 0 and 1. So is this probability. So when we add these probabilities, its sum is equal to 1. So therefore, this is also probability distributions. So on here, this one was probability distribution. This one was probability distribution, and these two, and the last two were also probability distribution. Now let's look at this example of probability distribution. So let X be the number of girls in 4 births. The probabilities are given in the table below. Here we need to find out what is the probability of having exactly 2 girls. So for us to answer this question, we need to look at probability when X equals to 2. So this means here. So therefore, probability of having exactly 2 girls equals to 0.3750. Here we need to find out the probability of having less than 2 girls. So we look at probability when X equals to 0 or when X equals to 1. We'll be looking at these two probabilities, which is probability of 0 plus probability of 1. So from the table we know probability of 0 is 0.0625 plus probability of 1 is 0.2500. When we add these two probabilities, we get 0.3125. So what that means is the probability of having less than 2 girls is 0.3125. So let's look at this question here. Here we need to find out what is the probability of having 2 or more girls. So here we'll be looking at these probabilities. So we are looking at probability of 2 plus probability of 3 plus probability of 4. From the table, we know probability of 2 is 0.3750 plus probability of 3 is 0.2500 and probability of 4 is 0.0625. So when we add all these probabilities, we get 0.6875. So basically, the probability of having 2 or more girls is 0.6875. Now let's look at this question here. Here we need to find out what is the probability of having even number of girls. So for us to answer this question, we will look at probabilities when x equals to 0, when x equals to 2, and when x equals to 4. Okay? So we will have probability of 0 plus probability of 2 plus probability of 4. So now we will need to add all these probabilities. So probability of 0 is 0.0625 plus probability of 2 is 0.3750 plus probability of 4 is 0.0625. So when we add all these probabilities, we get 0.5. So what this means is the probability of having even number of growths is 0.5. Thank you for watching. We hope this video was helpful. Please like and subscribe our channel. We will be bringing more and more videos on variety of topics.